You might remember the SwapMod video we did last year. It's very impressive. It just pushes off the build plate on your A1 Mini, slaps on another, and starts the next print. Very cool, but there were two big problems with it. One, it was only suitable for the Bambu Lab A1 Mini, and two, you had to buy a few build plates to get the most out of it. But you can auto-eject your prints on pretty much any other printer, even without the SwapMod. And it's weird because you don't find much information about this online, even for Klipper printers, and this feature is built into Klipper firmware, which is strange, but the information that I could find on it was minimal, and by itself it was not really applicable. So if you want to find out how to auto-eject and loop your prints basically on any printer, stay tuned. So this all started when I wanted to print more screw boxes for our pegboard behind us. Yeah, I'm sure a lot of you have this problem. There's screws everywhere. I sort of hoard screws a lot, so we needed some more organization. By the way, people have asked us about the pegboards here. You might have noticed that they are rotated 90 degrees. So the original IKEA hooks don't work. Yeah, people have addressed this, so I think it's time we actually said something about it. Yes, they are rotated 90 degrees. The reason for this is because we had to install a wall here, and then we couldn't fit the pegboards the right way up, so we rotated them. But seeing as we're printing all of the accessories for this anyway, it doesn't really make much of a difference. We can just print custom hooks and it works just the same. So now you know. Stop asking. Okay, back to our needs. So we wanted to print lots of little screw boxes for the pegboards, and the best way to print lots of the same thing is to automate your printer. Hence today's video. The easiest way to do this is with a Klipper printer. As mentioned before, this feature is built into Klipper, so it's really easy to do. So with the help of some G-code macros, you can set up any Klipper printer to auto-eject and loop your prints. Many thanks to the Mainsail and Moonraker website that gave us information on how to do this. However, it's not entirely complete. We're doing this with a K1, which has been decreolitized and is now running Klipper. First step, load your device page in your slicer. For the record, everything we're doing here will be on Orca Slicer, so use Orca. It's awesome anyway, just download it. Go to the machine options in your left toolbar and go to moonrake.cfg and add the following. You should also make sure that the following is also there. Now save and restart. This will set up a queue so one job will automatically follow the next. This is exactly what the first two lines do. The transition delay gives a delay of 10 seconds. Now you can change this if you wish, it's not a big deal. The transition code is the code that will be followed as the first print transitions to the next. So we need to set this up so that the printer will auto-eject the print before the next one starts. So now go back to machine settings and then to the G-code_macro CFG and add the following. This macro clears the bed between jobs. The first command waits for the bed temp to go down to 30 degrees, and 30 degrees worked for us with a standard 3D-Jake textured PEI, but you might need to experiment with this. G91 sets relative positioning, meaning the following move commands will be relative to the current position of the print head. G1 moves the print head up away from the printed part. In this case, it's only moving it 10 millimeters. G90 sets absolute positioning, so the print head will move to the XY coordinates of the print area rather than relative to the current position. The next G1 command moves the print head to right in the middle of the horizontal axis and also right to the back of the bed at a speed of 3000 millimeters per minute. The next G1 command moves the print head down so it is only 1 millimeter away from the bed, and G90 moves the print head forward to push off the model. And that's basically it. Now you can just slice your print as you would normally, send it to the printer, get a new file, slice that, send it, and just keep going, and it will set up a job queue. You'll see on Mainsail that a queue has started, and when the print is finished, it will trigger the clear bed macro, which will show up in the console, and then it will wait for it to cool down to 30 degrees before clearing the bed. However, you might get an error message. Klipper will be nice and tell you what the problem is in the console. When we first tried this, the error was that the printer needed to be homed, which was initially confusing because homing the printer would not be great when you have a model on the bed. but it became more apparent when I wondered why that specific error actually popped up. There is really only one reason why your printer needs to be homed, and that is to know where the print head is. So for some reason, the printer just didn't know where the print head was in this case. I checked the end G-code in Orca and it had an end print script, which is a macro. And if we check the macro list in Mainsail, we can see that that includes an M84 command at the end, and this disables your stepper motors. That needed to be deleted, and you can either get rid of offending G-codes in the macro list or simply replace the end print macro command in the slicer with basic end G-code, which is what we did. Also watch out for the purge line. We have been using a camp purge line, which we needed to get rid of. A couple of jobs with an overlapping purge line is probably not too tragic, but if you're piling them up again and again, it might be best to remove that purge line. Instead, we're going to use a small brim for all of our prints that will prime the nozzle. But I hear you, that's just setting up a job queue. What if you want to loop the same print? Well, you can do that with an SD_loop command. To do this, simply go to your printer.cfg and insert this command. It doesn't really matter where it is. This will allow loops for prints, but we need a G-code command to trigger this. And the best way to do this is to add the G-code in your slicer. I would set up a new profile for this so you can easily switch between them. In your printer profile settings, go to the machine G-code, and in the start G-code, add SDCARD_loop_begin count equals 5. In this case, I am telling it to loop the print 5 times, but you can change it to whatever you want, and if you want, you can go indefinitely by changing the number to 0. We're not using a job queue for this, but we can still use the same G-code macro for clearing the bed. You can either use the macro command in the end G-code or just paste the whole G-code script in there. After that, at the very end, include SDCARD_loop_end. This tells the printer that this is where the loop ends, so everything between SDCARD loop begin and SDCARD loop end will be repeated. Save that and then just start your print. If you only added the G-code to the end G-code in your slicer, then when the print is finished, the progress indicator will just stay at 99% until the temperature goes down to 30 degrees, and it will then clear the bed and restart. Hurrah! If you want to stop the loop at the end of the current print, you can just type in SDCARD_loop_desist in the console. We did have to change a few things in the start and end G-code to get this working perfectly. Firstly, I added the command to turn off the hot end earlier, before the end loop command. If you don't do this, then the filament will ooze and gather around the nozzle, so when it does start the next print, new filament will extrude but stick to the filament around the nozzle, and your first layer will be ruined. So that's for Klipper. What about other printers that don't run Klipper? Well, you can do exactly the same thing that we did with the end G-code to clear the bed. Just put it in the slicer like we did, and it will work. But what about looping? Well, for Marlin printers, you can actually do pretty much the same thing that we did with the SDCARD loop command. But for Marlin firmware, the command is an M808 command. And there's more information in the Marlin website, and there's a link down below for you to see that. It's pretty much the same process though. Lots of people still have Marlin printers, but what if you have a printer that's not officially Marlin or Klipper and you want to loop prints? Well, you can do it, but it's a little more DIY. What you can do is stitch G-codes together and then print those via your SD card or export it as a 3MF, which is just a compressed folder. Slice your file as normal, then export it to a plate sliced file in Orca. Open that as a zip archive, and in the metadata folder, open the G-code in a text editor. I would recommend Notepad++. Then select and copy the entire contents. If you want to just loop the print of the same object, then paste the code over the original as many times as you want to repeat it. If you want to set up a job queue with different models, then slice the G-code for that and copy and paste it in this one. When you're done, put it all back into the archive and open with your slicer again, and then you can see in the preview that the models overlap and the print time has changed. And then you can just send it off to the printer and it will auto-eject and repeat the print as many times as you repeated the G-code. I'm not sure who did this first, but Devin from Make Anything put up a video like 5 years ago doing this with a Marlin printer, and you can basically follow the same instructions that he did with a few minor changes. But if you're doing this with a Bambu Lab printer, A, P, or X series, then I would highly recommend checking out Factorian Designs videos on this. He does the exact same thing with the G-code, However, he goes into so much detail and put in so much work to get those G-codes absolutely perfect for those printers. The video is linked down below, check it out. These instructions will work for basically any printer. They all understand basic G-code commands like G0 or G1. However, there are some limitations. Let's talk about those. Firstly, this is not suitable for ABS or other high temperature materials because obviously you need to keep the door open for the print to pop out. For a lot of newer printers, the end_print macro can be complicated. There are macros within macros, and if you don't have a printer where the macros are visible and editable, you'll just have to replace it with a basic G-code script, which might result in some loss of functionality for the process of ending the print. Also on the K1 and other printers, you have to use the print head to push, or the belts will touch the model, which is probably bad. That means aligning the print head with the model so only the print head pushes it and not the belts. Now, for something like the BambuLab A1, it is okay if the rails push the model off. You also need space at the back of the printer for the print head to position itself for pushing, so for larger models this might not be possible. Small models with a very low Z height might have issues. You need some lever action to pry the model from the build plate, so this isn't going to work with something like a HueForge print. You might need to print a pusher plate for the printhead so it can push the model off easily. The K1 series printhead faceplate is the worst for this because it is curved at the bottom, so for smaller models you probably do need a pusher plate. Smaller prints might not be pushed off completely. You can tilt your printer a bit so that gravity can help remove it, but just remember to run input shaping after you tilt it. With bed slinger printers, you might run the risk of getting the model trapped under the build plate. You can stick a sheet of paper under the build plate to help roll it off. Knowing where your printhead or gantry is going to push the model off is vital. Before doing this with your printer, measure where the push will happen and use that as your value for the G-code script that you'll be entering in the macro or end G-code in your slicer. And when slicing your model, if you are using the printhead to push it off, you need to make sure that it is in the right position for the printhead to do this. So it's best to slice your model in the middle of the bed and also position your printhead in the middle when you're running your G-code script. I think the hardest part of this is actually making sure that your build plate can handle continuous printing. A good Z offset is obviously key, but you also need to make sure that there is enough bed adhesion for the next print. And this is one issue that we had with smaller objects where there was not that much area for the print to grab on. So please make sure that you clean your build plate before you use this method and just make sure that it has the best bed adhesion. Bed adhesion is better with larger objects, with larger footprints, so that might also be a concern. Start with a small object and work your way up to see what your build plate can handle, and be ready to turn off your printer if things go south. Clearly, if you're running your printer indefinitely, there will come a time when you need to clean or swap the build plate. The SwapMod and other build plate swappers like it don't really have this problem. At least it's not as bad. Also keep in mind the ambient temperature in your workspace. For Factorian Designs method, he used an auto-ejection bed temperature of 22 degrees. And for us, that didn't work at all because the ambient temperature in the office is always around 24 degrees. So the lower that number is, the better, the more reliable it's going to be, but it's also going to increase the wait time. There are upgrades to help. So firstly, there is the pusher, like we mentioned. So with the K1 series, the printhead is just really crap for smaller prints. And while there is little space for a pusher, it is possible to mount one. Tilting the printer is a great idea, but to decrease the wait time, you could install extra fans, which is what the Vertigo Mark I printer does for its ejection system. And actually Factorian Designs did this too with the fan plugging into the spare AMS slot on the A1. Genius. Thanks for tuning in, guys. If you have any questions on what we did today, you can let us know in the comments down below. And if you didn't know, we also have a Discord server where you can talk to us and everyone else about 3D printer upgrades and other such things. So until next time, later.